All right, this is going to be a video about molarity and different concentration calculations that we're going to do. So there will be kind of 3 different types. And before we jump into the practice problems, I just want to talk a little bit about what molarity is and the equation and how we're going to manipulate it. So molarity of a solution is the moles of solute in moles divided by the liters of solution in liters. Liters of solution, the units will be liters. So a few things we need to keep in mind before we do these calculations is that 1 liter is equal to 1,000 milliliters, so we need to be comfortable with that conversion. And then also this idea that when we see this capital M, which is molarity, that really means moles per liter. So these 2 units are within the capital M unit. And when we're given problems and stuff, we want to remember that if we're given grams, that's really similar to moles, and we know how to convert from grams to moles and vice versa. And then if we're given milliliters, that's really similar to liters, and we know how to convert that or vice versa using this conversion. And this is just talking about how we would say when we see this 2M, we can say 2 moles per liter or 2 molar. So you'll hear that a lot, like a 2 molar solution. So let's try a few practice problems. I'm going to do 1 of each type from the notes. So there's 3 different types of problems. What's the concentration? What's the amount of solute? And then how many liters can be made, or different variations of these 3 types. So you're either solving for a concentration, an amount of solute, either in grams or moles, or a volume. So we're going to start with the first type, which is what is the concentration, and I'm going to do part B here. And for part B, we are given 22 grams of sodium chloride in 1.6 liters of solution. I'm going to tell you right now, I'm using sodium chloride in all of the examples, just so that we're not getting hung up on the molar mass calculations. So we'll just have NaCl for all of these. Okay, so remember that this type of question is what is the concentration? And we're given the gram amount of sodium chloride, and we're given an amount of solution. If we want to figure out concentration, remember that concentration or molarity is moles of solute on top and liters of solution on the bottom. So what we can do is we don't have moles here, but we have grams, and that's really similar to moles, and we know how to convert that. So we can actually start with that 22 grams of NaCl, and that's going to be on the top, so that's kind of like moles, and on the bottom we need the volume, and we actually have 1.6 liters, so we can do that. And so we want concentration, or we want molarity, we want moles per liter, we have grams per liter, so it's not quite the same. So what we need to do then is do a conversion so that we can convert this grams into moles. And that conversion is using the molar mass of sodium chloride, right? So use your periodic table, calculate the molar mass of sodium chloride, so it's sodium plus chlorine, so 22.99 plus 35.45, you're going to get 58.44 grams as the molar mass of NaCl. And so since grams is here, I need to put that molar mass on the bottom. And it's always going to be 1 mole if I got those numbers off the periodic table. Normally, I know I write out NaCl. For this one, though, we're only dealing with NaCl, so I'm not going to worry too much about writing in that formula here, but I do need to worry about all my other units. I need to make sure that my grams cancel, so I show that. And so if the grams cancel, what we're left with here is moles on top and liter on the bottom, and that's exactly what we want for a molarity calculation, which is what this question is asking. So now we just type this into the calculator. So we'll do 22 divided by 1.6 divided by 58.44, those numbers are both in the bottom, equals this number, and we're only allowed to have, so this number has 2 sig figs, this number has 2 sig figs, so our answer can only have 2 sig figs, so it's going to be 0.24 because it's a 5 with other stuff after it. So this is greater than 5, so we'll round that up to a 4. And then the units here, you could write mole/liter, but it's, also molarity is capital M, so it's 0.24 molar, or 0.24 moles per liter for that one. So that's an example of figuring out the concentration. We have an amount on top and a volume on the bottom. You may or may not have to do extra conversions to convert to specifically moles on top and liters on the bottom. Okay, so let's try the next type of problem, which is the amount, when you're trying to figure out the amount of solute, and we're going to do part A here. And we want to figure out the moles of sodium chloride that are in 675 milliliters of 3.40 molar solution. So again, going back to our notes, this type of problem, we're trying to figure out, I'm going to fold this, we're trying to figure out the amount of solute. We want an amount. And if we look here, the amount is going to be something on top here. From molarity, it will be moles, but it could ask us for grams. So in order to get that, we want to break up the concentration, the molarity, into these two units, moles on top and liters on the bottom. So when you see this unit of molarity here, instead of writing capital M, you want to actually write out the hidden units that are within the capital M, moles on top, liters on the bottom. And it's always per 1 liter if it's given like this. So what I'm going to do is start with this number, and keep in mind that I want my final answer to be an amount. In this case, I want it to be in moles. It could be grams, like this question's asking for mass, but we want moles or grams or whatever the amount to be in the final answer. So it's good for us to set up the problem like this. So I'm just breaking this capital M. Capital M means moles on top and liters on the bottom. So it's good for me to break this up this way because I see that moles is in the top and I want my answer to be in moles. So I'm going to write it this way with 3.4 moles on top and 1 liter on the bottom rather than the flipped version. Because you could flip it, that's just inequality. What this says, this 3.400 molar, it means that there are 3.40 moles are equal to 1 liter of solution. So you can use that just like in our math unit. You can use that either way. You can put this on top and this on the bottom, or you can put this on top and this on the bottom. But for this type of problem, we want to have it this way because we want the amount as our final answer. Okay, so we want our answer in moles, so we need to somehow get rid of this liters. So if we read the question, this number can help us because it's in milliliters. So I'm going to write 675 milliliters here. And there are no other units on here, so I don't have to write anything in the bottom, or if you're uncomfortable just leaving that number, if you want, you can put over 1, but don't put any units. There are no other units there. But those don't actually cancel. Liters does not cancel with milliliters. So you're going to have to do another conversion to convert liters to milliliters. And that's this relationship here. Hopefully you have it memorized by now. There are 1,000 milliliters in a liter. I need milliliters on the bottom here so that it'll cancel this one. And that's equal to 1 liter. So now that liter cancels this liter. So the liters cancel, the milliliters cancel, and I'm left with moles, which is what this question specifically is asking us for. So now we just have to type this into the calculator. So we have 3.4 times 675 divided by 1,000 equals this number, and we are allowed to use 3 sig figs because both those numbers have 3 sig figs. And we have 2.295 with nothing after it, so this is fun. We get to use the odd even rule because it's exactly halfway between. And so since 9 is odd, we round up to 2.3, and to get that extra sig fig, we'll add a 0, and the units are moles. Okay. If you feel comfortable just converting this number directly to liters to cancel this without writing this conversion, so if you just plugged into the problem 0.675 liters, you are allowed to do that as long as you do it correctly. Okay, so that's the second type if we're solving for an amount of solute. We'll do the last type, which is when we're asked to calculate a volume now. So this is the last type, how many liters can be made. We're going to do part A. So in this one, we are given 32 grams of sodium chloride, and we have to make 1.5 molar solution. And so we're trying to figure out how many liters of solution will be made with that. And so this one, again, we have to use this relationship that molarity is equal to moles over liters. But here we're wanting our answer to be in liters. So there's a little problem because liters in this number, 1.5 molar, remember the relationship is 1.5 moles is equal to 1 liter. That's what's in here, right? The capital M is moles per liter, so it's 1.5 moles is equal to 1 liter. For this particular problem, since we're wanting to solve for liters, we want this to be on top. So that's going to be the best way for you to start the problem, is to have 1 liter on top over 1.5 mole. Okay, so this right here is using this number 1.5 molar. And we need to cancel at the moles here because we want a final answer in just liters. So we're somehow going to need to get rid of this unit of moles, and we can do that by using grams. We know that grams is related to moles. So similar to the last problem, if I put 32 grams here, I just put that because there are no other units. If you're uncomfortable, just put a 1 there. But moles does not cancel grams. You need a conversion factor that converts moles to grams, and that again is the molar mass. So we already did the molar mass of sodium chloride earlier, and it's 58.44 grams. So we need to put the 58.44 grams in the bottom so that it'll cancel here. And how many moles is that? Always 1, right? So now the moles cancel, the grams cancel, we are left with liters, and that is what we want our answer to be in, because it's asking how many liters can be made of this solution. So now we calculate. So we have, and here, this is a really tricky type of problem to plug into your calculator. You can't start with this 1.5 because that's in the bottom. So the best thing for you to do, you can either do 1 divided by that, or you can just start with some other number that's in the top. So I see a 32 in the top, so I'm going to start with that number. Then I want to divide by 1.5 and divide by 58.44. Right, and I get this number, and we're only allowed to use 2 sig figs because of these 2 numbers here. So it's going to be 0.37 liters. All right, so there were 3 problems that we just did. First was, what is the concentration? Then we did, what is the amount of solute? And then we did, how many liters? All 3 of those types of problems came from this relationship of molarity and your understanding of the units that are within this capital M, moles on top, liters on the bottom. It did require us to use some other conversions, like 1,000 milliliters in a liter, and the molar mass equal to 1 mole of whatever substance we're dealing with. All right, so good luck with those conversions.